Hello guys! Once again, welcome to another video in my course about microservice entitled Distributed Lag Tracing in Microservices using Spring Cloud Sleuth and Zipkin. This will be the last one for the microservice architecture, and next we will deal with the deployment. Hopefully, this set of videos were able to assist you in learning about microservices. To get updated when I upload the next set, please do subscribe to my channel and hit the bell icon. Let's start. This is our project architecture. Again, we have the microservices catalog and inventory, fetching data or fetching configuration from the Terra Warehouse config server, which uses the local Git repository. Both of our microservices registered to a service discovery powered by Eureka. And then we have our business API here, which calls the API from the catalog and inventory to get the product and stock data. And finally, we have our load balancer powered by Suul, which is directly accessible, which is the only service accessible by our clients. In this architecture, we have several microservices that communicate with each other to perform a single task, such as the Get Product Stock service in the Business API. This is a two-level deep request that pulls and joins data from the catalog and inventory microservice. This kind of architecture introduces some challenges, such as lag tracing across multiple microservices, with each service running several instances as well as the latency between each request hop. This is where Spring Cloud Sleuth comes in by adding metadata such as ID in the request header. These logs are aggregated using Spring Zipkin, which makes debugging easier. Here are the two types of ID added by Sleuth. Trace ID. It adds a unique ID whenever a new request is initiated, plus it contains a set of span IDs. Its value does not change across microservices. That's why if we generate a trace ID from the business API and this business API call another API such as the catalog, the trace ID remains the same. Number 2, span ID. It represents a basic unit of work, such as fetching a record from a database. We will provide a demonstration earlier for visual how to add Zipkin to our projects. Add Spring Cloud Starter Zipkin dependency to all the projects that we want to trace. This dependency. Number 2, add the following properties to the microservices that we want to trace. Spring Zipkin base URL. This is where the Zipkin server is running. Spring Zipkin discovery client enabled equals to false. This means that we will not be looking for the discovery client server for the Zipkin server because we have this URL. Alternatively, we can use the service ID. So if we are running Zipkin server as a Spring microservice, then we can use the service ID. But I think that is only available for Spring Cloud version lower than 2.0, 2.2, yeah. And then finally, we have the Spring Sleuth sampler probability equals to 100. It means all spans will be sent to Zipkin server. Here are those properties defined in our application properties. And we have added these properties to the catalog, inventory, as well as in the business API project. And before I forget, I have also added logback to each of the microservices that we want to trace. Here I have set the console logger to error level. In that way, we can minimize the error logs, and we can focus on the logs generated by our application. Now let's run the application. Run the microservices in this order. Again, if you have watched the previous video, you should be familiar with this setup. I have two computers running, the Node 1 and Node 2, and in Node 1, I'm running the config server, service discovery, and load balancer. In Node 2, where I'm doing the demonstration, I'm running catalog, inventory, and the business API. This is because these are 6 microservices which my computer might not be able to run or might slow down. That's why I have separated them into two sets. How to run Zipkin with Docker? We can run Zipkin with Docker, or we can run the standalone application. As long as you have Java installed, you can run it. But me, for demonstration purposes, I'm using Docker. You can go with the documentation, Zipkin documentation available at the end of this slide to download the runnable. So to run Zipkin with Docker, let's execute this command, which I already did in Node 1. Here, Docker run, open Zipkin. And by default, we should be able to access Zipkin via the IP address where we are running it, and port 9411. I think it auto redirects to Zipkin. Yes. And I have already started all the microservices before I have started this video. To check that out, we can check Eureka. Here we have the business API, catalog, inventory, and load balancer registered with our service discovery. Now that our applications, all our microservices are running, as well as the Zipkin, we can now demonstrate how we can trace the logs. In Node 2, open the Zipkin URL and then run the Postman collection inside the source main resources folder in the data warehouse catalog project, which is, it's in source test resources, which is this Postman collection. And if you open that, it should look like this. We don't need to run the we don't need to run the full collection, just the inventory folder. To do that, click display button and select the inventory. I have the Eclipse console to monitor the logs here. And let's try running the test. Start. There's one failure. So let's try that again. But before that, let's clean the database. Maybe I have left some data earlier. And hit retry. Or sometimes it could be the read timeout. Now all our tests passed, and we can check the logs. Now let's check the log for the trace and span ID. Let's start with the business API because it's the first microservice that is called by an external client. Here we can see that we have several logs. And the start of the whole is the get stocks from the product stock gateway. It should generate a unique trace ID unique to this request from start to finish. And that's why we have this. This is a unique span ID. Now this is a span ID for the find by product ID. And it has a unique span ID in the inventory service proxy that find by product ID as well. So as you can see, again, this is the trace ID, unique per request set, and this is the span ID, unique per method call or a set, or unique per task. Like in this one, it gets the detail of the product, and this one gets the detail of the stack. Now let's check the catalog microservice logs. Here we should see the same trace ID, which is this one, and then it has a unique span ID, and we should see the same values in the inventory microservice. Here we have the same trace ID we have from catalog and business API, and it has a unique span ID for this call, which is the query controller that binds all the requests all together, which makes tracing easier. Now let's copy this one and see if we can make something out from Zipkin. This is the Zipkin trace browser. In the left side, there is a dependencies page. We can actually, here we can click the search, and here we can actually see all the microservices and their interaction. Here we can see that the business API is sending requests to the inventory as well as in the catalog. Now, if we wanted to see more details, let's say we are tracing this log, we can actually, or we are tracing that specific trace ID, we can filter the log. And now we have this data. The request is started with the business API. It executes. So the whole execution takes around 83.83 milliseconds. And then it calls this is the historics. And then it calls the catalog microservice, which took 23.42 microseconds. Then finally, it calls the inventory microservice. In the right side, we have the detail for the business API get stocks request. And we can click the rows here. These rows are clickable. If you wanted to view more information, for example, for this request, click it, and here we can see that the method is get, and this is the catalog, this is the controller, this is the method, and the IP address. We can also show all the annotations, which click show all the annotations, and it will provide more information related to our request. Specifically, the start and stop time for the client and the server. Here are the references for the Zipkin. And we're done. Again, thank you for watching, and hopefully I'll see you in the next video. So don't forget to subscribe. Have a nice day and goodbye.